In this section, we're going to finally formally look at the quadratic formula. The quadratic formula is a tool, and the solutions of ax squared plus bx plus c equals 0 with a not equal to 0 are given by the quadratic formula. You can actually derive the quadratic formula from completing the square method. And if you're really curious about that, I would encourage you to try it. So we're going to solve some equations using the quadratic formula. Remember, you always have to set your equations equal to 0, get them in the form ax squared plus bx plus c, and then use the formula provided and substitute the values for a, b, and c. Simplify, and you get your 2 zeros of the equation. We're given 3x squared equals 18x minus 6. Rewriting it set equal to 0 gives me 3x squared minus 18x plus 6 equals 0. My a value is 3, my b value is negative 18, and my c value is 6. Using the quadratic formula, I have x is equal to 18 plus or minus the square root of b squared minus 4 times a times c all over 2 times 3. Simplifying inside the radical can be helpful if we use a calculator. Negative 18 times negative 18 will be a positive 18, so I don't even have to write the negative there. So 18 squared is 324, and then I need to subtract 4 times 3 times 6. So I get 252. X is equal to 18 plus or minus the square root of 252 divided by 6. Here is where your factorization tricks will come in very handy. If you recall, there are some ways you can identify prime factorization of a number. If I divide 252 by 2, it will divide evenly. This is because the last digit is even. If I divide 200 by 2, I get 100. If I divide 50 by 2, I get 25. And if I divide 2 by 2, I get 1. So this would be 126. The last digit is still even, so I can divide by 2 again. Half of 100 is 50, half of 20 is 10, and half of 6 is 3. This gives me 63. This number is no longer divisible by 2 because the last digit is not even, but we do have another trick for dividing. If the sum of the digits equals a number that is divisible by 3, then the entire digit number given is divisible by 3. If I divide 63 by 3, I know that 60 divided by 3 is 20, and 3 divided by 3 is 1. So 21 is the divided number. Now 21 I happen to know is divisible by 3, and I get 7. All these numbers now are prime. This is a great activity to practice your division skills to find the primes. So I know that 2 squared times 3 squared times 7 will give me 252. So to rewrite this, I have x is equal to 18 plus or minus the square root of 2 squared times 3 squared times 7, all divided by 6. These numbers will come out of the radical, and I get x is equal to 18 plus or minus 2 times 3 root 7 over 6. So my two solutions are x equals 18 plus 6 root 7 over 6, and x equals 18 minus 6 root 7 over 6. We are not done because at this point you probably noticed that there is a common factor in the numerator and denominator. 18 divides by 6 and so does 6 root 7. So I have x is equal to 3 plus root 7 and x is equal to 3 minus root 7. Those are my two solutions. Now let's take a look at part B. We have 3x plus x times x minus 2 equals 4. This gives me 3x plus x squared minus 2x minus 4 equals 0. I distributed the x inside the parentheses and I brought the 4 to the other side, so the equation now equals 0. I am going to now combine like terms to get x squared plus x minus 4 equals 0. Now you might be thinking you can prime factor this or just factor this and set the factors equal to 0, but the whole goal of this section is to use the quadratic formula. So we're going to, and I don't think that actually factors nicely, so let's use the quadratic formula. X is equal to negative b, so negative 1, plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 1, times c, which is negative 4, all over 2 times 1. Further simplification gives me negative 1 plus or minus the square root of 1 plus 16 all over 2. A negative 4 times a negative 4 is a positive 16 plus 1 squared is 1. So we add those together to get 17. So I get x is equal to negative 1 plus or minus the square root of 17 divided by 2. 17 is a prime number. It's not going to come out of the radical nicely, and so those are my two solutions. Lastly, we have a very interesting equation. We're going to have to FOIL the right-hand side, distribute the 14 to the binomial, and then distribute that negative to the other binomial. So we have 14x minus 14 times negative 4 is going to be 56. So minus 56 minus x minus 2 equals x squared minus 2x minus 8. Now we have to bring everything to one side of the equal sign, set it equal to 0, and use the quadratic formula. X squared minus 15x minus 8 plus 58 will just be plus 50 equals 0. Now we're going to use the quadratic formula. X is equal to negative b, so 15 plus or minus the square root of b squared, negative 15 squared, minus 4 times a, which is 1, times c, which is 50, all over 2 times 1. Let's see if we can simplify this further. X is equal to 15 plus or minus the square root of, and now let's figure out what 15 squared is. Which is 225 minus 4 times 50 is 200 all over 2. Well, this looks like it's going to simplify nicely. 15 plus or minus the square root of 25 all over 2. We know that the square root of 25 is 5, so we get x is equal to 15 plus or minus 5 over 2. Our two solutions will be x is equal to 20 over 2, or just 10, and x is equal to 10 over 2, which is just 5.